Hi there, this is Andrea with my Week 5 Advanced Interactive Concept. I'm going to be making a lemon battery, um, and I'm going to do that with copper and zinc. So I have copper clips and galvanized, this is a screw actually, and I'm going to show the redox reaction that's supposed to occur to make a spark, make a little fire. So you can see here. Alright, so that's my little piece of wool. And first thing I'm going to do is, I don't know how I'm going to set up the screen. Okay, so I got my lemon and I'm just squeezing it to release the juices because the acid in the lemon is what's going to generate the power of the battery. So first I'm going to put the copper clips in. This is kind of a smaller lemon, so it's not like tiny, but I know that apparently one lemon is kind of controversial on how much actual amperage it will put out. So I think I'm going to put the wire around the nail first. I can only get really thick picture hanging wire. So there I have the copper clips in the lemon. And I'm not going to go too far from it with the zinc. So basically making our negative and positive, our cathode and our anodes here. The nail is the anode. Oh man, I should have. This is a little sensitive. Okay. I'm going to talk while I'm doing this because it's going to take forever. So, just down here. Okay. So, yeah, like I said, the zinc and the copper are electrodes, and the juice inside is the electrolyte, which is acidic. Oh my gosh, it's hurting my fingers. So the series connection increases the voltage available. Hold on, let me pause. Okay, so I just finished the rest of the connections here, so it's not very pretty that you can see that the wires touching all the copper and the zinc together. And so the lemon is the cell, and when the cell is providing an electric current through an external circuit, the metallic zinc at the surface of the zinc electrode is dissolving into the solution. So zinc atoms dissolve into the liquid electrolyte as electrically charged ions, leaving two negatively charged ions behind in the metal. So this is the oxidation. And while zinc is entering the electrolyte, two positively charged hydrogen ions from the electrolyte combine with two electrons at the copper electrode surface and form an uncharged hydrogen molecule. And this reaction is called the reduction. The electrons used in the copper to form the molecules of hydrogen are transferred from the zinc through an external wire connecting between the copper and the zinc, and the hydrogen molecule formed on the surface of the copper by the reduction reaction ultimately bubble away as a hydrogen gas. So I'm going to put this one wire on the, oh, I forgot to put this last, oh, I don't have that much room. Okay. Should have moved them over. I'm going to do it over here. So I'm going to put one wire on this side and another wire on the other side. I'm gonna wrap that around the screw. Okay, so the energy comes from the chemical change in the zinc when it dissolves into an acid. The energy doesn't come from the lemon. The zinc is oxidized inside the lemon, exchanging some of its electrons with the acid in order to reach a lower energy state, and the energy release provides the power, as I said before. So the energy produced in the lemon battery comes from reversing the reaction, so recovering some of the energy input during the zinc production. So now I'm going to put it on the other side of the copper over here. Okay. And then since I don't have insulated wire, I'm going to use dishwashing gloves. And explain that during the chemical reaction, the reaction at the anode and generates extra electrons, which want to go to the positive end of the battery, but they can't pass through the electrolyte, so electrons must travel around the outside of the battery through the circuit to reach the cathode or positive end of the battery. So this flow of electrons is what generates the electricity to power or give us a spark here. So I have my wool, and then I have a little piece of paper that will encourage a little fire. It's also on top of paper towel, so I really shouldn't need that, but we're going to try to create this little spark here. And it's supposed to kind of short with the steel wool and create a spark. And nothing is happening, which is kind of what I thought would happen. So I did a little bit of research already before this, and this is really supposed to be more like in theory, because it is correct that it is becoming a battery, it is creating a little bit of energy, but it's in no way going to make enough energy to create a fire or power or anything. So despite what was supposed to happen, the thing is that it's basically not producing enough. So there's not enough maybe acid to create the energy that you would need to create a spark. Like a battery would need about a milliamp, and that's just not, we're not getting that from the lemon. So yeah, so basically the whole reason why it didn't work was that there's basically just not enough. So it might work if there was multiple lemons strung together with multiple connections and wires, but there's not enough. It just doesn't generate enough power to create a spark like that.